let's have a chat about algebra when we are dealing with matrices. So the first thing we need to just sort of be aware of is the order of a matrix. We need to know that we've got our terminology on the same page before we get started. So just a little reminder that the order of a matrix is the number of rows times the number of columns. So it would be a 2 by 2 matrix, or a 3 by 5 matrix, or a 1 by 4 matrix. Okay, the number of rows is indicated by the first number, the number of columns indicated by the second number. So for example, if we had A, B, C, D, E, F as compared to A, B, C, D, E, F, this first matrix, rows times columns, so 2 rows times 1, 2, 3 columns, whereas our second matrix, 1, 2, 3 rows times 1, 2 columns. So the reason that it is important to be aware of this is because we talk about the order of a matrix when we come into our algebra. And the big place it comes up is with addition and subtraction of matrices. In order to do addition or subtraction of matrices, they must be of the same order. We need exactly the same number and arrangement of elements in the first matrix as we do in the second matrix. So starting out with letters, A, B, C, D. If we were going to add or subtract, this is the 2 by 2, so we would need a 2 by 2 again, E, F, G, H. And then all we're going to do is we're going to take each element and we're going to add or subtract, depending on which one we're doing, with the element in the corresponding position. So top left plus top left, bottom left plus bottom left, top right plus top right, bottom right plus bottom right. If we were subtracting, it would be exactly the same pattern of combinations, just subtracting instead of addition. So we can write all that out as by saying, top left we would have A plus or minus E, bottom left would be C plus or minus G, top right, B plus or minus F, bottom right, D plus or minus H. So that's a whole lot of letters and a whole lot of symbols. So we're actually going to do a couple of examples so you can see one addition, one subtraction, and how they combine. Shout if you have queries as we're going through this. Our main focus of this lesson today is looking at multiplication of 2 matrices. So I'm going to move through this other types of algebra a little bit quicker than usual. Okay, so if something is going, huh, what? Then make sure you alert me on the chat. So an addition example, we could have, let's say 1 minus 5, 2, 3, plus 0, 2, minus 4, 1. So we are happy we have 2 by 2, 2 by 2, they are the same order. We have a bottom left and a top right and all of those in each of these matrices. So, and that top left position, we would have 1 plus 0. So we'd have a 1. We'd have a minus 5 plus a 2, so minus 3. We'd have 2 plus a minus 4, so a minus 2. And we would have 3 plus a 1, giving us 4. So you're just combining those elements which are in corresponding positions. If we had 6 minus 2, 1, 3, 2, 1, minus 5, 2, 2 minus 1, 0, 2. Okay, so again, we've got the same order. The number of rows in both is the same. The number of columns in both is the same. Here we've got a middle left and a middle right. So in both matrices, we need a middle left and middle right. So 6 minus 5 gives us 1. 1 minus 2 gives us minus 1. 2 minus 0 gives us 2. Minus 2 minus 2, minus 4. 3 minus minus 1 is 3 plus 1, so 4. And 1 minus 2 gives us minus 1 again. So there is our answer. And because we had two matrices of the same order to start with, we end up, our answer matrix is also of the same order. So to add or subtract matrices, both matrices must be of the same order. And then you are just combining the elements in the corresponding positions. The next thing we can do is we can take our matrix and we can multiply it by a scalar. So a scalar is what we actually call just our normal numbers. Okay, so 2 is a scalar, 3 is a scalar, a half is a scalar. It's just a plain old simple number. So if you think back to vectors, we talked about scalars and vectors. So we've got the same concept here, that a scalar is just a plain old number. Okay, but multiplying a matrix by a scalar is a very similar thing to multiplying a bracket by a number. We've got to multiply everything within that matrix. So if we had our trusty letters again, B, C, D, E would then be inside. So again, 2 by 2. So there's our scalar A, and there's our 2 by 2 matrix. Now, when we multiply by that scalar, same story, when we stick something together, it's still multiplication, even though it's a scalar and a matrix. We're going to multiply everything. So we would need A, B, A, D, A, C, A, E. We have 4 multiplications because we have 4 elements. If there are 10 elements in your matrix, then you are looking at 10 multiplications if you are multiplying by a scalar. So, an example, using actual numbers. Let's use our 1 minus 5 to 3 again. So 2 times this matrix means that we're going to multiply every element of this matrix by 2. So 2 times 1, 2. 2 times minus 5 would be minus 10. 2 times 2 is 4, and 2 times 3 is 6. So when you multiply by scalar, you've got that plain normal number outside, but you multiply by everything that is inside that matrix. Are we happy to move on now to the guts of this lesson? Moving on to how we multiply two matrices. Okay, coolness. So let us look at multiplication of two matrices. So the important feature here, okay, so remember we had an important feature for each of those other last pieces of algebra. Here, the number of columns in the first matrix must equal the number of rows in the second matrix. Otherwise, you can't multiply them. Okay, so number of columns in the first matrix equals number of rows in the second matrix. And then we have a series of steps to work through. What we're going to do is we're going to do one with numbers and work out the steps at the same time so that you can see what's going on. It's a little bit easier with these ones to look at in terms of numbers rather than just in terms of letters. So let's say we want to multiply our 1 minus 5, 2, 3 is the matrix of the lesson. 0, 2, minus 4, 1. So, same as always, if things are stuck together, it's an implication of multiplication. So these two matrices are being multiplied. And it's going to equal something. So the first thing that we are going to do is we're going to circle the first row in the first matrix. Just like that. Okay. The second thing we're going to do, I wonder if we're going to have enough colors to do this, is we're going to circle the second thing we're going to do is circle the first column in the second matrix. And what you see now is we've got two things in our pink circle and two things in our orange circle. And that is because the number of columns in the first matrix equals the number of rows in the second matrix. Without those pink numbers equaling orange numbers, you can't do the multiplication. So our next step is going to be to multiply and add. So we're going to take 1 times 0, okay, which is 0, and 2 times 2, which is plus 4. So we take the first number in our circle and multiply each of them. Then we're going to add the multiplication of the second number in each circle. Then we're going to circle the second column. So it's a column, so it's hiding there in the second matrix, because our second matrix is the one that's all about circling columns. And guess what we're going to do next? We're going to multiply and add. Same idea. Okay, but now, see how we've done 1 on the left. Now we're doing 1 on the right. So we move to the right. 1 times minus 4 is minus 4. 2 times 1 plus 2. So now we've got two numbers in our new matrix. Then, who comes next? The second row. Because we've multiplied that top row by everything. So we're going to repeat with the next row. So minus 5 times 0 gives us 0. Plus 3 times 2 plus 6. Minus 5 times minus 4 gives us 20. 3 times 1 plus 3. And then, of course, we are very close, because all we have to do now is simplify. All of these are numbers in here, so we can actually do these additions. And we get 0 plus 4 is 4, 0 plus 6 is 6, minus 4 plus 2 is minus 2, and 20 plus 3 is 23. So it really is a case of circling sideways in the first and circling columns in the second. Okay, so when you wake up in the morning, you are lying flat in your bed. When you get up, then you're standing straight. So first matrix, lying down. Second matrix is standing up. And then you work systematically through all of those multiplications and additions until you've got all the positions in your new matrix, and then you simplify to your answer. So I've got a few more examples to work through so that we can see this pattern coming over and over again. So how about 6, 1, minus 2, 3 times 5, 2, 2 minus 1 equals. So even in exam, take a pencil, circle the first row, circle first column. Helps you keep track of where you're working on. So we're starting in that top left. 6 times 5 is 30. 2 times minus 2 is minus 4. And I have to admit that my hand is like shaking around a lot here, because when I do these on paper, I've got my finger over that bottom row when I'm working with the top row. So there's nothing wrong with using your finger on your piece of paper to help you keep a track of where you are working. So we've done the top left. We now circle our second column with our pencil. And then we do that one. So 6 times 2 gives us 12. Minus 2 times minus 1 plus 2. And then we put our finger over the top row, because now we're working with the bottom row. 1 times 5 is 5, plus 3 times 2 is 6. 1 times 2 is 2, plus 3 times minus 1 is minus 3. So we've got all 4 positions. We just need to simplify those expressions. So we have 30 minus 4 is 26. 5 plus 6 gives us 11. 12 plus 2 is 14. And 2 minus 3 is minus 1. So again, I repeat, it is systematically working through a series of additions and multiplications to do these questions. So let's have a look at 1, 2, minus 5, 3 times 1 minus 3 minus 2, 4 equals. Same story. When you wake up in the morning, you're lying flat in your bed, and then you get up to start the day. So 1 times 1 is 1. 2 times minus 3, minus 6. Done with that one. Circle the next one. 1 times minus 2 is minus 2. 2 times 4 is plus 8. Then we work on the bottom. Minus 5 times 1 is minus 5. 3 times minus 3 gives us minus 9. Minus 5 times minus 2 gives us 10. And 3 times 4 gives us 12. And then we simplify. So 1 minus 6 gives us minus 5. Minus 5 minus 9, minus 14. Minus 2 plus 8, 6. And 10 plus 12, 22. We've got enough space and we've got enough colors. So let us do one more. So 3, 1, minus 2, minus 4, times 1, 2, 3, 1. What does this one equal? And again, doesn't matter how many of these you've done. The thing is that, let's make this more exciting. Let's put some more minuses in it. Okay, and that's exactly why. It doesn't matter how many times you've done these, you're still going to need to work through them systematically, because it's so easy to make a mistake with a sign. It's so easy to make a mistake with lining things up. So when you have this approach that you can just repeat and repeat and repeat, it helps you to not make as many silly little mistakes in your calculations. Okay, so first one, we circle the row. Second one, we circle the column. 3 times 1 is 3, plus 1 times 2 plus 2. Then we circle our next column, helping us to keep track. 3 times minus 3 gives us minus 9. 1 times minus 1 gives us minus 1. Then we move to our bottom row. Minus 2 times 1 is minus 2. Minus 4 times 2 is minus 8. Minus 2 times minus 3 is 6. Minus 4 times minus 1 is plus 4. And then we can combine all our numbers to get that final matrix. 3 plus 2 is 5. Minus 2 minus 8 gives us minus 10. Minus 9 minus 1 also gives us minus 10. And 6 plus 4 equals 10. And that answer was completely unplanned. Sometimes when you make up sums out of your head, then they go completely wonky. And sometimes when you make them up out of your head, they go completely cool. So the multiplication of our 3, 1, minus 2, minus 4 times our 1 minus 3, 2 minus 1 gives us 5 minus 10 minus 10, 10. A very funky answer. Okay, so when it comes to multiplying matrices, it is really important that you get yourself happy with that systematic working through. Circle, circle, multiply and add. Circle, multiply and add. Next row, repeat. If you've got more rows and more columns, carry on all the way until you've filled up your new answer matrix, and then you go and you simplify with all the additions and or subtractions, depending on if you've got positive or negative numbers that you're working with, and you get your final